In this video, we want to determine the sum, difference, product, and quotient of functions f and g. Then we will determine the domain of each. So starting with the sum, one way to write the sum of functions f and g is to write f plus g of x. And we would write it this way. So this is read f plus g of x, but this is communicating mathematically to us that we want to basically take function f and add it to function g. So these are two different ways of communicating the same thing mathematically. We want to add these two functions together. So function f is a rational function, 3 divided by x minus 2. And we'll add it to function g, which is also a rational function, 4 divided by x plus 7. So since these are both rational functions, which means we have fractions here, we are going to need to get a common denominator. So our least common denominator, I'll write off to the side here, our least common denominator will be x minus 2, the quantity, times the quantity x plus 7. So our first fraction, which is 3 divided by x minus 2, it needs the x plus 7. So we will multiply both the numerator and the denominator by x plus 7. Remember, by multiplying both the top and the bottom, that looks a little messy, sorry, let me clean that up for you. By multiplying both the top and the bottom by the quantity x plus 7, we're really multiplying by 1. X plus 7 divided by x plus 7 is really just 1. Then the second fraction, 4 divided by x plus 7, it needs the x minus 2. So we'll multiply the numerator by x minus 2 and the denominator as well. So now, looking at the denominators, this denominator is x plus 7 times x minus 2, and this denominator is also x plus 7 times x minus 2. So we have a common denominator. So we will just go ahead and add the numerators. So the first numerator is 3 times the quantity x plus 7, and we're adding that to our second numerator, which is 4 times the quantity x minus 2. And that is all divided by the common denominator, which is x plus 7 times x minus 2. And I realize that I have written this denominator in the reverse order that I had written it over here when I wrote the least common denominator. But remember, when you're multiplying, the order doesn't matter. That's called the commutative property for multiplication. So now let's go ahead and distribute. So we'll distribute the 3x plus 21. We'll also distribute the 4x minus 8. And I would want you to leave the denominator factored. The denominator right now is already in factored form because it's written as a multiplication, as a product. So we want to leave it factored because in the end, we might find that this expression simplifies. And finally, we'll combine like terms. So remember, we have a 3x and a 4x, which we can add together to give us 7x. And we also have a 21 minus 8. Which is positive 13. So we would end up with 7x plus 13 in the numerator, and that is all divided by x plus 7 times x minus 2 in the denominator. Now, typically we'd want to look at this numerator and see if we could factor, if there was a greatest common factor, but we don't have a common factor between 7 and 13, so that tells us that we cannot simplify this anymore, and we are done. So that is the sum of functions f and g. So now let's move on to the domain. So the domain, when we do a sum of two functions, is going to be the intersection of the domains of the two individual functions. So I'm going to go back to the beginning here, and I am going to go ahead, there we go, next to function f of x, let's write down the domain for function f. So I like to use a big capital D to represent my domain, and since I have two different functions here, I'm going to use a little f as a subscript to indicate this is the domain of function f. And since we have a fraction, we have a denominator, we know that we cannot have 0 in the denominator. Therefore, x cannot equal 2 in this case. So my domain is going to be all of the x values except for 2. All real numbers except for 2. And that can be written as an interval, negative infinity to 2, union 2 to infinity. That's all numbers except for 2. And if you want to be fancy and write x is an element of these intervals, you could use that notation as well, although that's not required. Now for the domain of g, we have a similar issue because it also contains a denominator. We cannot have 0 in the denominator of a fraction. So the domain for function g is that x cannot equal negative 7. So I'll use a capital D for the domain and a little subscript of a g here. And my x values can be all values except negative 7. So that would be from negative infinity to negative 7, union negative 7 to positive infinity. So those are the two individual domains for functions f and g. So the domain of the sum, and this is going to be true for the difference as well, it's the intersection, which means we're looking at where the domains overlap. So x cannot equal 2, and x is also not allowed to equal negative 7. So if you think about a number line here, we're going to basically be skipping over negative 7. So negative 7 is not in the domain. We're also going to be skipping over 2. 2 is not in the domain. However, every other real number is in the domain. So all of these values here to the left of negative 7, all the values in between negative 7 and 2, and all of the values to the right of 2 are going to be in the domain. So I like to sometimes graph it on a number line to help me see what the domain is going to look like in interval notation. So the domain of function f plus g will be all of the x values from negative infinity to negative 7, union the values from negative 7 to 2, union the values from 2 to infinity. So this is the intersection of both the domain of function f with the function g. Next, let's compute the difference of these two functions. So to write the difference, we can write f minus g of x, and we can also write that as function f of x minus function g of x. Remember again, these are two different ways of communicating the same mathematical idea, that we're subtracting two functions. So function f will be 3 divided by x minus 2 minus 4 divided by x plus 7. So just like when we did the sum, we need to get a common denominator again, and the denominator will be the same as last time. So we'll need to multiply the first fraction by x plus 7 in the numerator as well as the denominator. So I'll show that here. I know some students get to the point where they don't have to actually show the multiplication, and that's great. But if you still need to write it, that's fine too. We'll multiply the second fraction by x minus 2 divided by x minus 2. So we'll end up with 3 times the quantity x plus 7 minus 4 times the quantity x minus 2, all divided by that common denominator, which is x plus 7 times x minus 2. And remember, I'm going to leave that denominator factored. Next, let's distribute. So distributing will give us 3x plus 21 minus 4x. Be careful here because we are going to need to distribute the negative with the 4, so we'll end up with a positive 8, all divided by x plus 7 times x minus 2. And then finally, let's combine like terms. So we end up with a negative x plus 29 divided by x plus 7 times x minus 2. And we cannot factor anything in the numerator, so this is an acceptable answer for the difference between these two functions. Now for the domain of the difference, so I'll write the domain of f minus g here as a subscript. Again, it's the intersection of the two individual domains. So my domain of f, I copied from what we did previously, here is all values except for 2, and the domain of g here is all values except for negative 7. Therefore, the overlap of these two domains will be all values except for negative 7 and 2. So the domain of the difference really is going to be the same as the domain of the sum. So all values of x, and the interval would be negative infinity to negative 7. We skip over negative 7. That's what those parentheses basically are telling us. We're not going to include negative 7, and we will also exclude 2, so we're using parentheses on both of those values. Moving on to the product, we could write this as fg of x, or we could also write that as f of x times g of x. Either way is acceptable. So this time we're multiplying these two functions. 3 divided by x minus 2 times 4 divided by x plus 7. And now we do not need a common denominator. We simply are going to be multiplying the numerators and multiplying the denominators. So we just need to remember how to multiply fractions. So 3 times 4 in the numerator will multiply to give us 12. And the denominators, I'm going to leave them in factored form, x minus 2 times x plus 7. I'm not going to bother distributing because ultimately we want to simplify this expression, and leaving the denominator factored with multiplication here, that's going to be far better just in case the numerator would have something that would divide out with the denominator. In this case, nothing divides out, so this expression is fully simplified. So this is going to be my product. Now the domain of this function, just like the sum and the difference, is the intersection or the overlap of the domains of functions f and function g. So the domain for function f times g will be all of the values except for 2 and negative 7. So that, written as an interval, will be negative infinity to negative 7, union negative 7 to 2, and union 2 to infinity. Finally, we have the quotient. So now we want to divide the two functions. We want to take f divided by g. So f over g, or f divided by g of x, which is also the same as f of x divided by g of x. So let's divide these two. However, we have to be careful because these two are fractions. Remember, they are rational functions. So we end up with a division that looks like this. And just so you know the name of this, an expression in this form, this is often called a complex fraction. So when we have a complex fraction, we ultimately want to change the division here to multiplying by the reciprocal. This means we will have the numerator, which is 3 divided by x minus 2, and now we will change the division to multiplication by the denominator, the reciprocal, of the denominator, which will be x plus 7 divided by 4. And now we're back to multiplying two fractions. So we essentially are going to be multiplying the numerators and multiplying the denominators. So in the numerator, I will have 3 times the quantity x plus 7, and the denominator will be 4 times the quantity x minus 2. And I know many of you really want to go ahead and distribute the 3 and distribute the 4, but again, I'm going to urge you to leave your final answers factored. Because if, let's just say, I'll give you a little example down here. Let's just pretend like this had been 3 times x plus 7, and the denominator had been 4 times x plus 7, and you had a common factor in the numerator and the denominator, then we would divide out x plus 7 and x plus 7, and we would have had a final answer of 3/4. But we would only have been able to see that if the expression was in factored form. So always try to leave your answers factored. Now let's finish up with the domain of this quotient. So the domain of f divided by g. And again, it's the intersection, the overlap of the two individual domains. And we know for function f up here that x was not allowed to equal 2. I also know for function g that x was not allowed to equal negative 7. So therefore, we're going to have to include both of those restrictions in the domain of f over g. So my domain will be all values of x from negative infinity to negative 7, and then from negative 7 to 2, and 2 to positive infinity. So you have to be careful with the quotients because on occasion I have seen students just look at their final answer here and think that the only restriction was that x cannot equal 2. And if you do that, you have forgotten that you have to include the overlap, the intersection of both function f and function g's domain. So we must also include that restriction that x cannot equal negative 7. And the reason why x cannot equal negative 7, if we look at our very initial division here, if we substituted negative 7 into that original division problem, you would see we'd end up with division by 0 in the denominator there, which would be no good.